Okay, bro, so I could not actually wait. I had to try and get it done. Okay, so what one approach that I thought I could try was well, see, we will start. Okay, leave it. We have this linked list, right? So I'll start both of them. Okay, I'll travel to the end of the list, right, with a pointer, right? So we have C, and we'll go with to the end of the list. I'll put T at here, right? Then I'll start another loop where I will check if C uh, is not equal to T, and what I will do is I'll keep swapping and like I'll keep swapping them, and then I'll make another variable x which will reference this. Then I'll move it up to just before at this point. Then I will swap it. Then I'll then current will move towards this, and temp will move here. Okay, then we'll reset x to bc again, right? Okay, let me just try it because I just want to. Let's go, dude. Okay. Okay, so first let's obtain the end and current. So we go current equals to head and end equals to head. Then we'll so while end, right, while end dot next. So end equals to end dot next. So hopefully I would have the end value right now. I think. Okay. None type has an attribute next, while end dot next, while end dot next is not equal to none. Maybe that's how it will work. Okay, and equals end dot next. Non attribute. Okay, there we go. That's the first problem. While end dot next. See, right? I'll go end dot next, while end dot next. What do you want me to do? This? Yeah. In the end and current. Last expected input head. Won't even run the test cases. open test case, case 3, case. If not head, return head. I don't know. Okay. Right. So yep. Okay. Got. Then I want to go while char is not equal to, and we'll go x equals to char. Then okay. From the head, while end is next. Variables for current node and end node. Obtaining the and node. Okay. So while current or end are not equal, what I want to do is first, okay, the first operation is to swap this and this. So how can I swap? Okay. It is malfunctioning, man. Okay. Right, okay. Swap the nodes. So I want to swap these nodes. How can I go on swap them? Okay, I'll set that next of, okay, first I'll store the next in an value x, then I'll say that this node um bruh, I have to linear, well, let's say x goes to clear, then I go, well, x dot next is not equal to n, that is, I have this, my xf here. So what I will say is that is next Then okay, well, x dot next is not equal to end, right? I'll keep on moving it. So now my x is here. Now how do I swap these nodes? I would say right, I want to attach the next of this node to be this. Uh, okay, reverse list. Right, I have my x here and I want to reverse these nodes. Okay, if I go current dot next is equals to can I just say that okay, I want to put this node here. How can I put this node here? Let me just 1, 2, 3, 4, and 5. Okay, I want to swap these nodes. So how can I swap these nodes? I have just before so what I will do is I'd say that this end is end and we have current. I would save I would say that I'd say current uh, I want to attach this node here, right? I want to attach 4 dot next, that is x dot next equals to x next equals to c. Right. See here. I'll say dot next and dot next. I'll save and dot next somewhere. Okay, I have x dot next equals to c. Now I will save Okay, hold up. Start next is not equal to end. Then I would say that x dot next equals to current, and equals to current, and x equals to e dot n dot next. So now this is this thing. Now I would say current x dot next equals to current. I would say n dot next equals to current dot next, and current dot next equals to x, and then we swap. Now my end is here and my current is here. Now I say current and equals current, and then I say x equals okay, let's see what the fuck this gives. Okay, I get expected 5 4 3 2 1. Swap nodes. Dude, I'm going crazy. Mm, okay, then it's like I store the and I keep on swapping values. Keep on swapping value. We have the current and I have the end. Then I swap their values. Right. Again, I say. Then I feel yeah. Swapping values. I feel like is bro. Don't what graphical in the hell is this, bro? Thank you. This don't work out. Okay. Get end, and then while current is not equal to and x equals to current, I'll say current dot value equals to n dot value. Okay, swap their value. Swap their value. And then I will go x if x equals to current, right? Okay, while x dot next is not equal to end. X equals to x dot next. And if we get there, then after I have reached x dot next equals not equal to end, let's say end equals x, I just move it. Okay, and also I increment current equals current dot next. Then let's try. Well, x dot next and x dot next is not equal to end. Well, current and end and give me something. 5, 4, 3. Ooh. Okay, I feel like I was really for okay, it's a 2 2. Say current value. Okay, so I didn't swap it. I basically just so in order to swap, I will first say temp val equals don't val equals temp val. Okay, got this. And equals x. Okay, see what I have done is it works basically, but not for size. Why is it? Why is this glitching so much today? I don't. What is up with the graphical glitches? Okay. Okay. Let just swap temp value while current and current is not and current is not equal to um acha. So we swap these values, then I move end here, and then I move current here. Then well, extort next. Now current, now we have end. We swap the values, move current here, and Okay, what would happen in current is less than okay, then that while current is not equals to end okay, or end dot next is not equal to current. Output 1 2 1 contributed test case 3 empty uh, def swap. It's a it would take optional list node x comma y template x dot val equals y dot val and y dot val equals template. Swap current first step. Okay, and then say x dot next is there and x dot next is not equal to and so increment, then we okay, let's see, swap is not defined, def swap self, sorry, I think it will run now. Okay, so we're getting somewhere. Okay, so what happens in this case? Current is not equal to end, and end dot next is not equal to current. Okay. So what happens is we swap these values, then I increment x, I don't want so many cases, right? Even size, list of even size. Uh, current and end and current not equal to end, or end dot next is not equal to current. I feel like this condition won't develop. Okay, listen to it. Again, let's take a look at it again. Right. Okay. 1, 2, 3, 4, 5, 6. I'll say current and end. Your first step, is swap value. Swap value. Then we swap values. Then what I will do is, after swapping values, what I can do is I will increment current to here, right? I'll go current dot next. Okay, so I would immediately do that after swap. Current equals current dot next. And I want to do it here. I'll say via x dot next. Current, then I run x while x dot next is not equal to right. Okay, so right after this I increment current, then I run x up to it is valid up to the end, right? Okay, please, for the love of God, man, please, man, please don't do don't do this to me. Don't do this to me. Please fix it. Yes. Okay. Okay. Well, current and so do I feel like I have to check for head? Will it fail? No. Okay. So it's simple while current is not equal to and okay, I find the next if not head, we swap it and we set and equals to next. Let's try and submit it and see what we come up with. Wrong answer. I fucked up somewhere. Okay. I swap. Okay, what happened? Let me check what happened in case of this. 1, 2, 3, 4. I had current here. I had here. Why do I keep calling it leads? And okay, so expected output. Okay, it didn't swap these ones. Okay, swap. Why did it? Okay, it did an extra swap, which it shouldn't have done. So let's check out what happened there. We had I swapped, I increment current, I run x, this is x. Okay, hold up. After the first swap, it would look like 4, 2, 3, and 1. So now my current is here, my end is here. I say I run x, so x obtained here, e becomes this. Then I go swap. Right, so I need to put this condition or while current is not equal to end. Okay, right, my e becomes here. We swap. I get this. 3, 2, 1. And now I increment current, right, to this. Now current or E are the same. It should stop there. Then why didn't it stop? I swap, I increment current, I set x equals to current, while x is the next, and that next is not an end equals to x. No. Use just case. Yep. Okay. Run. Okay. I found. Okay, let me check what is happening here. Let's print. Let's print current before swapping. Right. Okay. Print for dot well, then and dot. Okay, see. Then these perfect and perfect. Nothing to say. Okay. Okay. 1 and 4 swapped. Done. 2 and 3 swapped. Then I get 2 and 1. How do I get a 2 and 1? This doesn't support visualization. How do I get a 2 and 1? Right, if I go through, then okay. Before swapping, then after swapping, before swapping. Okay, but why? I feel like swap current equals current dot next. So let me just see what current dot next. Okay, I'll say before incrementing current, print for incrementing current. Current equals current dot next. No, okay. I want to print x dot well. How many times does this go in the loop? 2 times. Right. Okay. It swaps. Then it stops at 2. Okay, 3 and 1. X dot well is 3 and 1. Okay, I think I would have to print the fucking. Array. Okay. Mm, Well, temp dot temp equals head while temp print temp dot well. It's done. We say temp equals temp dot next. So, okay. See, 4 2 3. क्या हो गया? अच्छा बाद में करना आपको. Um, ये loop current is not equals to end. अच्छा, at the end of the loop, what are the values of print? ये यार current और end. See, current 2 और end 3. अच्छा ठीक है. फिर end पीछे क्यों नहीं आया? ये यहाँ से हिला क्यों नहीं यार? Okay. So while x dot next and x dot next is not equal to end. मैं इसको इंक्रीमेंट कर रहा हूँ. End equals to x. ठीक है. तो सी यहाँ पर with some reason wait. Okay, why did it do that? Wait, current. Let's see. Okay, let's go step by step. See, देख यहाँ तक हो गया था. It was done, literally done. But see, current current is 2 and 3. Current is 2 and 3. And x dot next. And x dot next, which is basically see my end was okay, end was 3. Then okay, see in the starting end was 3. Then we swapped these values. End was 3. Then I swapped these values. Then it became current was 2, but end should have been 2 as well. And should have been C in other cases, right? C, 3, 3, 1, 1. Whatever. But in this case, and was here, but for some reason it jumped to, and I don't know the reason for that, right? See somewhere. Okay, print list. Okay, so somewhere between the second iteration, uh, after it was done, these values incremented for some reason. I don't know the reason for that. So for after. Okay. See, also I would like to print list. Hmm. Okay, before for okay, it swapped. It was 4 2. So current was 2 and was 1 before. Okay, so it fucked up here. X equals current and end. Okay. Or x is not equal to n. And okay, now it fucked up here. 503. Okay. Right. current. Just fucking just check at the end. If current equals to end exit, if something has a break. Almost. Okay, we swap it. Drop the value. Increment current. I go find element just before end. See, I said I think I'm almost there. I feel like I'm almost there. But okay. So before they were well, okay, what if I remove I'll X out next? Will this make a difference? None type. I'll X out next and X dot next is not equal to it. I feel like this condition should have been true because my logic is right. Logic is right for the most part here. That it is at current too, right? We say and x is not equal to n. So many cases. Find the element just before end. Place end with it. Obtaining that node. Alright. If I submit it. Fucking slow. Okay, at least I did it. Right. Okay, I did it by myself with all these weird conditions and swapping, swap, increment. So we'll into next. Okay. Then what could you have done? Help me, Mr. Greg. Big 10. I give. It's too difficult, man. It was like, and I guess I'll understand it if I.
Hey guys, Greg here. Let's solve reverse linked list, LeetCode 206. It's basically the canonical first linked list question you should ever do. So given the head of a singly linked list, we want to reverse the list and return it. And that means return the new head. So say we were given the list of 1, 2, 3, 4, 5. We need to reverse it, which means basically flip around all those arrows and return the new head. So the new head is going to be 5, and completely reversed, it's 5 points to 4, points to 3.
Hey, 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 hey. Okay, 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 okay. I got another idea. Just got another idea. Let's check this out. Okay. So say we have this right. 1, 2, 3, 4, and 5. I'll obtain the end. I'll say that I'd say this is the head. Then I will take this node and attach it here. And I will make this the head. So then it would be 2, 3, 4, 5, and 1. But then again, I don't know. I would know. Won't I know when to stop? Then I make this end. No, this is 2.
3, and so on. And by the way, this notation from LeetCode often confuses people. This is not saying that head is actually like a list or an array. It's a way of kind of quickly representing at a high level that this is what the list looks like, and this is what you'd output. So you'd want to return the 5 node, which is the new head. Okay, so I should note there's actually 2 ways to cover this, and that's generally always true for linked list problems, is that there is usually a recursive solution because they are a recursive data structure, and there is also an iterative solution. And a lot of people get confused by the word iterative because people don't actually say it that much, but really you can just treat it as not using recursion, as in not creating a function that calls itself. Now in this video, we're going to cover the iterative solution because that's the one you'd want to cover in the interview. However, there is definitely a recursive solution, and I'd encourage you to try and figure that out afterwards. Okay, so the solution goes like this. We're going to use 2 pointers, and people immediately are going to get mad at me for saying pointers. Variables are basically pointers, and this precisely shows why. So we're going to use 2 pointers. We'll have a pointer cur. I'm just going to call it C. So we have pointer C that's going to point to our current head. And we'll also get another variable prev, which is basically going to point right behind it. And right behind it is currently nothing. So this is actually just, in Python, you'd call it none, or JavaScript, it's null, or whatever you want to call it there. It's nothing. So prev is always going to stay one step behind cur. And they are going to kind of move over like this. So if you wanted to write this in code, which I often encourage you to, we'd set cur equal to the head, and we would set prev equal to none, or basically null. Okay, so let's just have this over here and let's build up our code. This is definitely the best way to tackle linked list problems, is to draw it out like this and kind of build up your code. So we have our initialization, and then what do we want to do? Well, we really want to flip this around. We want it so that 5 is actually pointing to nothing. Why do we want that? Well, remember, we actually want it looking like this. And so really, we want 5 pointing to nothing. Well, that's great because prev is already pointing to nothing. So we can just set cur.next over to prev, and we are going to lose this connection. Uh-oh, well, that's a problem because we've already lost this whole list here. So that's not quite right. We are going to do that in a moment, but before we set cur.next, we actually want a temporary. We want a temporary t. This is going to be pretty common because you don't want to lose the list ever. So we set a temporary t to be what? Well, that is just cur.next. So over here, I'm going to write some code that is basically the stuff that'll run in a loop. We'll worry about the loop conditions later, but we know we're going to keep doing t is equal to cur.next here. And over here, I'm writing them in 1 letters. Here, I'm writing them in the full letters, but we don't actually really need this. That's just our initialization. So in our loop, we want to set c to cur.next, which precisely does this right here. So now we at least have the list over here, so we're not going to lose that. Then from here, we want to flip around this connection. So we draw this. That is precisely c.next. We are setting that equal to prev, or p. And so that draws the left connection. It also removes that connection. And then we really just want to keep this up. So we want to keep prev 1 step behind cur, and we want to move cur over. So we set prev to be cur. So let me find room for that here. We are going to set prev, that's just p equal to cur, p equal to c. And then we're going to get c equal to t. So then we do c equals t. We can kind of forget the fact that we have t. And really what this means here is that p is pointing here and c is pointing here. That is great shape because we can do the same thing again. We just really follow the code over here that we've already written out. Step 1 here, t is equal to c.next. Okay, we can do that. T is c.next. c.next is equal to p. Okay, we can do that. c.next is equal to p. That draws that connection and removes that connection. Then we can do these two. P is equal to c. Okay, so we point this at what c is pointing to, and we point c equal to t, which is right there. We can kind of forget about the fact that we have t, and these are all in the right spot, and we've done all of these operations. Okay, so I'm not going to really mark it with an X over here because we're just going to keep doing the same things, but I will quickly draw it out. We have T marks over here. We can reverse our connection by saying C.next is equal to P. We can move these over like we did before and forget about the fact that we have T. We need to do this a couple more times. We again get T is pointing over here. We reverse our connection, so C.next is equal to P. We move them over, and here this is the last time that we're going to do this. I'm just going to move my code over here now. So we have C pointing to what we want as the new head, because ultimately this is what we want to return. But when we do this, we'll have T is C.next. Well, that's fine, but now T is going to point into nothing. Again, that's just none or null or whatever you want there. So T points to nothing. We can still do our reverse. So we'll point this backwards, and then we will move these over. That points C to be nothing and P to be the new head. So this works out really well. You can actually run this while cur. So this is just while C here. That means while C is actually a node. So while it's a node, we are going to do this stuff. And then as soon as this breaks, that is when C goes out of bounds, basically, when it's none or null. Well, P is exactly the node that we want to return. That is the head. And so after you do this loop here, we can actually just return prev. That is exactly the node that we want. Okay, so let's write our code, and it's literally just the code we had there. That's why you should always solve it like that. So we have cur is equal to the head. We have prev starts at none. We will do our loop while we have cur, so while cur is a valid node and not none. We will get our temporary t, I'll just call it temp, that is equal to cur.next, so we don't lose the list. We'll set cur.next equal to prev, that is what is going to flip this around, and we move them over, so we set prev equal to cur, and cur is going to go over to the temporary. After that, we know when cur goes out of bounds, prev is always going to point to the head, and so we want to return prev. That is fully correct. It is literally the code that we wrote in the visualization. If we were to submit that, that will work. Okay, so let's think about the complexity of this. Now, time complexity for linked lists is almost always the same. You're probably going to have to go through the list, and that's really just what we do. It is going to be big O of n, where n is the length of the linked list. We really just run this while we have current, with current starting at the head. It's always going to take one step at a time, so the time complexity of this is definitely big O of n. And the reason that the iterative solution, which is the one we wrote, there's no recursive code here at all, that is actually going to be a space complexity of O of 1. Because as you can see here, we're really just storing some pointers. Yes, I'm calling them pointers, they really are. And we are not really storing any array values or anything. Now, the reason that this is better than the recursive solution, which if you were to write, I'm not going to show it, but if you were to write one, it would end up being O of n, because the recursive call stack actually ends up being the length of the list as well. So that's why we're showing this solution. It's more elegant and it's actually a lot better on the space. This is the best solution you can have, and it's insanely elegant. Drop a like if this.
Okay. So I have one, two, four, and five. We have the current here, previous here, and temporary here. We move them and set current dot next equals to none. No, sorry. First, okay. Temporary variable here. First, we'll say that current dot next equals to none. Then previous equals current. Previous equals current, and then previous dot no, I want him to point here. Right, I want it to point this way. So current dot next equals to previous. Okay. The current dot next equals to previous, which is none. Okay, so I lost and t equals to current dot next. So we have t here. I've just removed this connection and pointed it to p. Then I will say that p uh, p current c. Then I will say that c is equals to t. C is equals to t. So now c, okay, p. First I took p here to c. Then I took c, c, and then I say that t is equals to t dot next. Okay, got it. Sure. And at the last, all the connections are flipped. Like this is none, this is this, and C and T would be here and P would be here. So we would point the previous current equals to head and prayer equals to none. While current, you would say that current temp equals to current dot next. Temp equals current dot next. Then I'll say current dot next equals P and P dot next equals P. Right? We flipped it current to point to P. Then I say that P is equals to C and C is equals to T. Equals to current equals to temp, current equals to temp, and temp equals to temp. Now temp equals to current dot next. Current, wait, okay. We have previous here, we have current here, and we have temporary here. I attach current to previous, right? Then I move previous to current. So now so current is here, previous here, and temporary is here. And I will move current to temporary. So 1, 2, 3, 4, 5. So I have my previous here with pointing to this. I have my temporary here as my current here. And I say temporary equals to current dot next. Okay, then we simply are you sure this is right? Okay. Is something wrong? Preview, prev, def. Unexpected indent. Okay. Yeah, क्या हो गया? Indentation. Okay. Let's try it in C++. Create mount current goes to right and goes out. Then I want to point next to previous. Then I want to give previous the value of current. Then I want current to take the value of depth.